So basically what this means is on Sunday at 8 p.m. on the first week of January, Azure will take the yearly backup and retain it for 10 years. Hello and welcome everyone. In this video, we're going to look at how to create a virtual machine in Azure using the Azure portal. The portal provides easy to follow steps to have a machine ready in a few minutes. This video assumes that you have a Microsoft account and you're able to log in into the portal. But just in case you don't have a Microsoft account, then see how to get to the console through the link in the description section. And without taking any more time, let's begin. To start, you can use any of the following options. 1. On the homepage, Azure will usually keep your most recent resources on top of the page for quick access. Click on or hover over virtual machines. Click Create, then select Azure Virtual Machine, and that should take you to the VM creation wizard. Option 2. You can use the search bar, and typing VM, then selecting virtual machines, will open the virtual machine creation wizard as well. Option 3. Click on the list icon at the top left corner of the window to open the list of Azure resources. Then click on or hover over virtual machines, click Create, and select Azure Virtual Machine. And this should take you to the VM creation wizard. Now, the wizard has a number of tabs in which you provide the virtual machine's parameters. Starting with the basic parameters, we need to select a subscription for the VM. Basically, this is a logical billing group for resources on Azure. For this demo, I already have an existing subscription. You will need to create your own. Next, select the resource group for your virtual machine, if one exists already. So, a resource group is a collection of resources that share the same lifecycle, permissions, and policies. I really like this about Azure. This capability is quite powerful because it simplifies resource management. Talk about lifecycle management. You may want to deploy a number of virtual machines, web apps, storage, or even databases for some purpose. And once you're done using these resources, you simply delete the resource group, and this will delete every resource within the group. We don't have a resource group for this case yet, so click on Create New, and this will pop down a small window for you to enter the resource group name. And I'm going to name this one PlayRG. Then click OK. Then give the virtual machine a name. I will name this one Play VM. Next, you need to select where you want to host your virtual machine. It's always best to choose a region closer to you or your customer for lower latencies. So for this case, since I'm in Kenya, I will select the closest region, which is South Africa now. For cases where you need some level of availability and resiliency for your virtual machine for continuity, Azure provides a couple of options. Option 1 is Availability Zone, which physically separates your resources within an Azure region. So here we are talking about having this virtual machine in more than one data center within South Africa North. And this option handles a whole data center failure scenario. When this occurs, your virtual machine will still be available in the other data center. Option 2 is Virtual Machine Scale Set, which distributes virtual machines across zones and fault domains. And when I say zones, I'm referring to option 1. That is, the capability to have this virtual machine deployed in more than one data center within South Africa North, and Azure does this behind the scenes, by the way. Option 2 also provides fault domains, and basically this refers to physical racks which have independent power and networking within a single data center. So Azure will deploy and run this virtual machine in more than one of these racks within a data center. This way, if one rack fails, your virtual machine is still available in the other rack. Option 3 is Availability Set, which distributes virtual machines across multiple fault domains. So basically, option 2 is a combination of option 1 and option 3. But since this is just for demo purposes, I will not select any of these options. You also have the option of selecting the security type for your virtual machine. Select standard if you need basic security for your virtual machine, for example, basic username and password combination. Select trusted launch virtual machines. If you need advanced security features like Secure Boot, which helps protect your virtual machine against bootkits, rootkits, and kernel level malware. This option also comes with the Virtual Trusted Platform module in cases where you need to validate your virtual machine's boot integrity. The third option is Confidential Virtual Machines, which is still in preview. For this case, I will just stick with standard for security type. Next, choose the base operating system or application for your virtual machine. Azure provides multiple options For this case, I will choose Windows Server 2019 Data Center Gen 1. You also have the option of searching for and selecting your desired operating system or application from Marketplace, just in case it's not on the dropdown. The Marketplace provides you a wide variety of base images to select from. Since what I need is already on the dropdown, I do not need the Marketplace. Now, for scenarios where your workload is not urgent and can handle interruptions, you have the option to make the virtual machine a spot instance. Basically, what this capability does is to offer unused Azure capacity at a discounted rate versus pay-as-you-go prices. This means you have to ensure that your workload is tolerant to infrastructure loss, as Azure may recall capacity of the virtual machine. If you choose to go with this option, you will be asked to specify exactly how you want Azure to handle the eviction of your virtual machine using the eviction type and eviction policy options. With the eviction type, you can choose either of two eviction methods, and these are capacity only and price or capacity. The capacity only method will allocate capacity to you up until Azure requires the capacity back, while the price or capacity method will allocate capacity to you until either the virtual machine's price is greater than your set maximum price or until Azure requires the capacity back. Eviction policy allows you to choose what happens to the virtual machine when it's evicted. Upon eviction, the virtual machine can either be stopped and deallocated if you plan to redeploy or need access to the disk after eviction, or the VM can be deleted to clean up the VM and disks. But since I do not require a spot instance for this demo, I'm going to uncheck this option. Next, you need to select the size of your virtual machine. The size that you choose determines factors such as processing power, memory, and storage capacity. Azure offers a wide variety of sizes to support many types of use cases. In case what you want or need is not on this dropdown, click on See All Sizes. And this opens up a wider range of size options for you to choose from. From here, you can filter and sort the list using the various properties that are available. For this demo, I'm going to sort the list using the cost per month property because I need the cheapest sizing available, and that is B1S. You then need to specify the access credentials for the virtual machine, starting with the username. I will call it Azure VM user, and the password. Next, you need to allow inbound traffic into your virtual machine, and for this case, the defaults will work for us because we need to RDP into the machine. Although you have the option of allowing additional traffic from other protocols as well. And the last option on the Basics tab allows you to use an existing Windows Server license for cases where you have one, so that you can save on the virtual machine's running costs. But since I don't have one for this case, I'm going to leave this unchecked. Next, we need to set up the disk for the virtual machine. Choose the type of disk for the virtual machine's OS, and this is determined by your workload type and budget. For high performance and a more accommodating budget, go for the premium SSD. For slightly less performance at lower cost, go for the standard SSD. And for non-critical workloads at lower cost, go for the standard HDD. For this demo, I'm sticking with the premium SSD. Delete with VM allows you to retain the disk after you delete the virtual machine. Uncheck this option for cases where you might need to keep the data in the disk. And when you enable encryption at host, what happens is that encryption starts on the VM host itself. That is the server that your VM is allocated to. The data for your OS disk and temporary disk caches are stored on that VM's host. When you enable this option, all this data is encrypted at rest and flows encrypted to the storage service where it is persisted. Essentially, encryption at host encrypts all your data from end to end. But if you choose to use this feature, you must enable it at subscription level. Follow this link for the commands to do that. Next, select the encryption type. And Azure allows three options. Option 1. The OS and data disk caches are encrypted at rest with either platform managed keys, meaning Azure provides encryption keys, or option 2. Customer managed keys, meaning you provide the encryption keys. Or option 3, double encrypt with both your keys and Azure provided keys. For example, if a disk is encrypted with platform managed keys, then the cache for that disk is encrypted with platform managed keys. And if a disk is encrypted with customer managed keys, then the cache for that disk is encrypted with customer managed keys. And if a disk is encrypted with double encryption, Then the cache for that disk is encrypted with both platform managed keys and customer managed keys. But for this case, I'm going to stick with the default. Select the Ultra Disk option in cases where you need the disk to deliver high throughput, high IOPS, and consistent low latency. Ultra Disk is suited for data-intensive workloads such as SAP HANA, top-tier databases, and transaction-heavy workloads. Though it looks like this feature is not supported yet in South Africa North, and I don't really need it for this demo. The feature might be supported in your region though. Now, this next section provides the capability to add additional data disks for your virtual machine. And you have the option to either create and attach a new disk or attach an already existing disk. Clicking on Create and Attach a New Disk opens up the disk creation wizard, where you get to set up the disk parameters, and this includes the disk name. The second parameter is the source type, where you can select snapshot if you need to use an existing image that you might have saved in your subscription. You can also select storage blob if you have your image in object storage, and you have the option to browse for that image, or select none if you just need an empty disk. The size option allows you to choose the disk type and size, and clicking on Change Size opens up those options for you to choose from. Next, you get to choose encryption type, and the same encryption options exist as we saw earlier. Then choose if you want to share the disk and the number of shares, or not. And lastly, choose if you want to delete the disk as you delete the virtual machine. But since I do not need an additional disk for this virtual machine, I'm going to cancel out of this. This other option provides you the capability to browse and add an already existing disk in your subscription. But since I don't have that and I don't need it, I'm going to leave it at that. Now, for best performance, reliability, scalability, and access control, Microsoft recommends Azure Managed Disks for most virtual machine configurations. Like for this case, the OS image selected can only work on managed disks, so this option is grayed out. And in cases where you want the disk to be created on the local virtual machine storage and not persisted to the remote Azure storage, then go for the ephemeral OS disk options. But for this to work, the VM instance has to meet the size requirements of the OS image. Next, we define network connectivity for the virtual machine. And we begin by setting up the network interface parameters. Now, you will notice that Azure already has default values for these parameters, which in most cases, like mine, you won't even need to change any of them since they will work for you. Azure will automatically create a virtual network for your virtual machine, then create a subnet range, and assign the VM an IP in the subnet. It will also open up the relevant ports on the VM. But for cases where you might want to customize these settings, then you have the option to create a new virtual network. This opens up the Create Virtual Network wizard, where you get to specify a name for your VNet, specify the address range. Here you can use the default range, or add additional ranges. Although you need to ensure there is no overlap with existing ranges, but Azure will warn you in case of an overlap. The same applies if you need to specify the subnet range. You can go with the default subnet range as well. And you also have the option to add an additional range or ranges. And again, you need to ensure that there is no overlap with existing ranges, or Azure will warn you just in case. But for this demo, let's work with the defaults. Azure will automatically assign a public IP for your virtual machine. Use this if you want to communicate with the virtual machine from outside the virtual network. Otherwise, select none. The next setting allows you to configure security at the NIC level using a network security group. And basically, this is a set of security rules that allow or deny inbound network traffic to or outbound network traffic from the virtual machine. Although, Azure recommends that you associate a network security group to individual subnets rather than individual network interfaces within the subnet whenever possible. Basic is the default option that allows you to select the type of traffic that Azure should let into your virtual machine. For this case, I will leave it at that, though this would mean that any IP address can access the virtual machine. To limit traffic to non-IP addresses, select the advanced option to manually configure the network security group. Click on Create New, and this opens up a wizard where you can get to do just that. Here, you can use your preferred name for the network security group, add an inbound or outbound rule, and clicking on the Add an inbound rule link will open up a child window for you to specify the role parameters. Specify the source of the incoming traffic, and this could be any or an IP address, or a range of IP addresses, or a service tag. Specify the port. This could be a single port, a port range, a comma-separated list of ports and port ranges, or an asterisk to allow traffic on any port. Specify allow destinations for this rule, and this could be an IP address range, or a service tag as well. The service specifies the destination application and port range for this rule. And here you can choose a preferred service like RDP or SSH, or provide a custom port range. Select protocol type for your traffic, TCP, UDP, ICMP, or all. Choose an action for this rule, whether to allow or block traffic defined by all of the above parameters. Prioritize the rule, and remember, the lower the number, the higher the priority of the rule. And finally, give your rule a preferred name and a description if you wish. For cases where you need to control traffic originating from this machine, you will need to set up outbound rules. And the parameters are pretty much the same. But for this demo, I'm good with the basic option. Now, public IP addresses and network interface cards persist independently from the virtual machine. You can choose to automatically delete the public IP address and network interface cards when this virtual machine is deleted. Select accelerated networking if you need low latency and high throughput on the network interface, though the VM size I'm using for this demo does not support this capability. For instances where you have more than one virtual machine running your workload and have the need to distribute traffic among them for good performance, this is the place to do it. Select Azure Load Balancer if you want to distribute traffic at layer 4. And this gives you the option to pick an already existing one or create a new one. And that's a subject for another video. Or you can select Application Gateway if you need to distribute traffic at layer 7 with additional features such as URL-based routing, SSL termination, session persistence, and web application firewall. Again, this provides the same options, but for this demo, let's use none. Next, we configure monitoring and management options for this virtual machine. Here you will already have Microsoft Defender protecting your subscription under the basic plan. Use boot diagnostics to troubleshoot boot failures for custom or platform images. Boot diagnostics with a managed storage account significantly improves creation time of the virtual machine by using pre-provisioned storage accounts managed by Azure. But in case you prefer to set up your own custom storage account, then select the second option, which allows you to create one. Here you get to specify the name of the storage account, the account kind, the performance, and replication type. Now, I will talk more about these features in a later video on how to set up a storage account, but for now, we stick with the recommended option. For cases where you need OS level diagnostics information of your virtual machine, select this checkbox, and again, you will be required to create a storage account to store this information. Now, you might want this virtual machine to authenticate to other Azure Cloud services for secure interactions. The System Assigned Managed Identity provides this capability. Once enabled, all necessary permissions can be granted via Azure role-based access control. The lifecycle of this type of managed identity is tied to the lifecycle of this virtual machine. Additionally, each resource for this case, this virtual machine can only have one system-assigned managed identity. If you need to use your corporate Active Directory credentials to log into your virtual machine, enforce multi-factor authentication, and enable access via airbag roles, then select the Azure ID option. And this automatically enforces a system managed identity for the VM. Auto shutdown allows you to configure your virtual machine to automatically shut down daily. Selecting this checkbox allows you to set up shutdown time, time zone, and notification email for pre-shutdown alerts. This alert will also allow you to skip or delay the shutdown procedure. Now, depending on your workload type, you might want to guard your virtual machine against accidental deletion and corruption. Backup feature provides this capability. Your virtual machine will be backed up to a recovery services vault with a configured policy, and there will be charges for the backup. Clicking on Create New will open a side pop window, allowing you to specify the resource group, the name for your vault, select the policy subtype, and you should know that standard policy will not support protecting newer Azure offerings, such as multiple backups per day, trusted launch VM, Ultra SSD, shared disk, and confidential Azure VMs. Stick with enhanced subtype if you need support for these features, though for this demo, let's use the standard subtype. And clicking this link will allow you to create a backup policy for your virtual machine. Specify the policy name, specify the backup frequency. Do you want it daily or weekly? What time is best to run the backup? And select your time zone. Snapshots allow you to create instant recovery points for your virtual machine. And this option allows you to specify how long you would like Azure to retain the latest snapshot. Configure how long you like Azure to retain the backups, and Azure will use this information to store your backups either in cold or archive storage. Specify a number of days for daily backups, and basically what this means is Azure will take the latest backup at 8 p.m. daily, then retain it for 30 days. Specify day and number of weeks for weekly backups, and this setup means Azure will take the latest weekly backup at 8 p.m. on Sunday, then retain it for 12 weeks. As for monthly backup retention, choose if you wish to use the weekly backups, and specify on which day of which week of the month you would like to run the retention process, and how long the backup should be retained. What this means is every Sunday at 8 p.m., Azure will take the existing backup of the first week of the month and retain it for 60 months. Select day-based option if you wish to use the daily backups, and specify day or days of the month and the retention period. And on every first day of every month at 8 p.m., Azure will take that day's backup and retain it for 60 months. The setup is similar for retention of yearly backup, except here you get to specify on which month you like Azure to run the retention process. So basically what this means is on Sunday at 8 p.m. on the first week of January, Azure will take the yearly backup and retain it for 10 years. Select the day-based option if you want to be specific on a particular day. For this instance, on the first day of January at 8 p.m., Azure will take the yearly backup and retain it for 10 years. But for this demo, we don't need any of these options. Now, Azure Backup Service normally creates a separate resource group to store the instant recovery points of managed virtual machines. It uses a default naming format as stated on this information tab. This last option allows you to customize the name as per your requirements. Again, since I do not need this for this demo, I will cancel out of it. So, for instances where you want to take critical and security updates for your virtual machine without restarting it, enable hot patch option, although this is only supported for Windows Server 2022 Data Center Edition. Patch orchestration options allow you to control how patches will be applied to your virtual machine. Choose automatic by OS if you want the patches to be controlled by the operating system. This is best for scenarios with interruptible workloads. Choose Azure orchestrated if you want patches to be applied across availability sets. This is best for scenarios with uninterruptible workloads. Alternatively, you can choose to do it manually by logging into the VM and invoking the updates similarly the way you would do on your PC. Next, we add additional configuration, agents, scripts, or applications for this virtual machine. With extensions, you can add new features like a backup agent, a monitoring agent, or antivirus protection. Clicking on this link opens up a list of available extensions you can use. Selecting an extension and clicking Next will open up a configuration window that allows you to input all the relevant parameters for that extension. But for this demo, I do not need any extension for this virtual machine, so I will just cancel out of this. Now, suppose you have your own application that you need to install on the virtual machine after its creation. The VM applications feature allows you to do just that, although you will need to create your VM application package in Azure Compute Gallery first, and that is a subject for another video. Initially, and even currently, you have to create an image of the VM with your applications pre-installed, and you will need to update your image each time you have application changes. Separating your application installation from your VM images means there is no need to publish a new image for every line of code change. This feature opens up a window where you can select your VM application from. But for this case, since I do not have or need a VM application for this demo, this window is empty. You might need to inject a script or other metadata into the virtual machine while it's being provisioned. Custom data option allows you to do just that. Custom data is made available to the VM during first startup or setup. For instance, you might want to create a folder on the root drive or start up an application using a script. This is the place to do that. Although there is a, can I call it a limitation specific to Windows virtual machines for this option. The file is not processed. Rather, all that Azure does is place the custom data in a specific folder location under the root drive as a binary file. And then it's up to you to write code to process the bin file after the VM has been provisioned. So probably what your code will do is convert the bin file into a batch file and then execute the batch script. Now, user data is a new version of custom data. It also allows you to pass your script or metadata to your virtual machine. And on top of that, it offers added benefits like the user data can be retrieved from Azure Instance Metadata Service after provisioning. User data can also be retrieved and updated from outside the VM via REST API call without having to stop or reboot the VM. Please see the link on how to go about performing these actions in the description section. So, suppose your workload type requires isolation at the physical server level, probably to meet security or compliance needs. Azure Dedicated Host is a service that provides physical servers able to host one or more virtual machines. Basically, these are the same physical servers used in Azure data centers provided as a resource. Though you will need to provision the group within a region, availability zone, and fault domain first, so that you can select the group at this point to place the VM directly into your provisioned host. And that is a subject for another video. The next option is capacity reservations. This feature enables you to reserve compute capacity in an Azure region or an availability zone for any duration of time. Unlike reserved instances, you do not have to sign up for a 1-year or a 3-year term commitment. You can create and delete resources, or rather the reservations, at any time, and you have full control over how you want to manage your reservations. Again, you will need to provision the capacity reservation group first so that you can select it at this point. And that's a good subject for another video. The next option is proximity placement group. This feature is a logical grouping used to make sure that Azure compute resources are physically located close to each other. Use it for workloads where low latency is a requirement. Again, you will need to provision the proximity placement group first, subject for another video of course. Next, we set up tags for this virtual machine. These are key value or name value pairs that enable you to categorize resources. Normally comes in handy when you need to view consolidated billing by applying the same tag to multiple resources. For instance, you could choose to categorize your resources by department, per team, or per environment. All you need to do is specify the name, value, and resource, and further specify whether the tag applies to some or all the resources tied to the virtual machine. But for this demo, I need none of this. And finally, we review and create the virtual machine. This page provides you the cost of running the virtual machine and a summary of all its configuration that we've just set up. Now, suppose you have the need to repeatedly deploy virtual machines with similar or customized configuration in the future. You have the option of generating a deployment template in JSON format which you can reuse to quickly deploy either using the portal, CLI, PowerShell, among others depending on your preference. Or you can integrate the template into your CI/CD tools which automate your release pipelines for fast and reliable infrastructure updates. The template guarantees you consistency by ensuring you get the same resource types in the same state with any repeated deployment. You have the option of either downloading it to your local machine or adding it to the templates library under your subscription. But since I have no need for a template for this demo, I'm going to cancel out of this. Now with everything in check, click Create to deploy the virtual machine. This will take you to the deployment page that displays the deployment process and all the resources being created for this virtual machine. It normally takes a couple of minutes, so I'm going to pause the video at this point and get back once the deployment is complete. And now that our virtual machine is ready, click on Deployment Details if you wish to see all the resources created linked to the VM. Besides the virtual machine itself, Azure also creates a network interface, a VNet, an IP, and a network security group for the VM. Azure also provides a set of recommendations for you to consider. Even though these options are available during setup, at this point you may want to set up auto shutdown to save on costs by inputting the desired parameters at this point. Or you may want to enable monitoring, for which you will be required to set up a log analytics workspace to store monitoring data. Or you may want to run a script, and Azure allows you to use your own scripts or use the available predefined scripts. Click on Run to execute the script inside the virtual machine, and you will be provided with the output, if any, on this bottom section. Clicking on Go to Resource will take you to the VM's Properties and Management page. This page provides a view of the virtual machine's features including status, location, size, public IP address, among others. It also provides management and administrative capability using the top menu items or the side menu items. Click on RDP to connect to the virtual machine. And this will take you to this page that allows you to download an RDP file. Open the file and input your login credentials. And there you go. Your virtual machine is ready for use. And with this, we come to the conclusion of this video. Please share any thoughts or questions in the comment section, and don't forget to leave a like, subscribe to my channel, and click on the bell icon so that you're notified whenever I post similar videos. Bye and see you in the next one.